Hi, this is Scott Ritchie, and this video is just a short video on treating or correcting flow mismatch by changing my inspiratory flow pattern. In a previous video, I showed treating flow mismatch by just changing my flow rate, and this is going to show different flow patterns on how they affect my inspiratory flow rate. Now I have my simulator here, and we're currently in volume control ventilation. That's where I have these flow asynchronies, this flow mismatch. And here are my current settings. I have a respiratory rate of 10, a tidal volume of 500, a PEEP of 5, and if I look at my controls, I have my flow pattern set to a square or a constant flow pattern, and some ventilators allow you to do this. And then my IE ratio is 1 to 2.5, which is a common IE ratio, and this gives me an inspiratory time of 1.71 seconds. Now, some ventilators allow you to set an inspiratory flow rate. However, to set my inspiratory flow rate, I need to manipulate my inspiratory time or my IE ratio. Just going to close this out. I'm going to look at my peak pressure here. And here's my flow, and you can see my flow rate's pretty low, and my measured values, we're going to look down here in the lower left portion of the screen, and it might be hard to see, but my inspiratory flow right here is 18 liters per minute. And my patient, currently my patient, I have the patient condition as a normal patient condition. They're not adding any spontaneous rate at the time. And I'm just going to give minimal effort when I do, and they have a normal compliance and very little resistance. And I'm going to start to change this. Now let's just start to add a patient rate. I'm just going to change the rate to, let's say, 8 breaths per minute and confirm that. And we'll see the patient start to spontaneously breathe. If I look at my dynamic lung here, you can see the diaphragm moving here, so I can see spontaneous breaths. And as we notice that the pressure waveform is starting to scoop out some here. So the inspiratory flow of 18 liters per minute is not really, it's pretty much giving them enough, but they might need more. I'm just going to change that effort, a little more. And I'm just going to change the patient to 5 centimeters of water effort. And what we're going to do before I confirm this value, we're going to look at this pressure waveform, and we're going to see how it changes. I'm going to confirm that. And you notice that my pressure waveform is starting to change. I have this scooping, mid-inspiratory flow scooping here. So this is an indication, this is flow mismatch, that my flow rate's not appropriate for the patient's inspiratory demand at the time. And instead of just increasing my flow rate, what I'm going to do is I'm going to just change from this square or constant flow wave pattern to a decelerating flow pattern, kind of like pressure control ventilation. So under my controls, I'm going to switch my flow pattern to a 75% decelerating pattern. And let's see what this does to my flow rate. So if I look at my measured flow rate, it's going to change it to, instead of 18, my inspiratory flow rate is now 23 liters per minute. I didn't do anything with my I time or IE ratio to change my flow rate. It's just my flow pattern changing my flow rate. Now I have less scooping, pressure scooping, so it helped a little. Now I'm going to go back and I'm going to change my flow pattern again to a fully decelerating flow pattern. There we go. So now I'm fully decelerating. And I'm just going to confirm that. And it changes my inspiratory flow. If we look at the left bottom corner of the measured value screen, you can see the inspiratory flow is 35. And I pretty much have gotten rid of that pressure scooping at the time. And that was just changing my flow pattern. And if needed, if the patient needed more inspiratory flow, which they kind of do, I can just go to my controls. And I can change my IE ratio, which will change my inspiratory time, and it will change my flow rate also. So let's see this 1.1 to 3.3 change it to 1.4 seconds. inspiratory time, and that changed my inspiratory flow to 43 liters per minute. And as you notice, I'm getting rid of that pressure scooping and have appropriate flow rate setting. And I'm just going to give a little more flow. Just change my IE ratio again, changes my inspiratory time, and my inspiratory flow is 49, approximately 50. And now I have no pressure scooping at all. So the flow asynchrony is treated. So this video demonstrated that I can change my flow delivery pattern, which will create a higher inspiratory flow. So by changing my flow pattern from a constant waveform to a fully decelerating, the patient gets a higher inspiratory flow rate at the beginning of the breath. Thank you.